Hi and welcome to a new course in which we will talk about CDK testing for Python with Pytest. And in this course we will talk about different testing techniques for AWS CDK code. You can see on the screen what we will talk about. Also you can use the video outline for different chapters about fine-grained assertions, about matchers, captors and snapshot testing. All the code inside this course is available in the description as a Git repository, and also in the description you will have a full professional link to a CDK course. This being said, let's get to work. Alright, and let's start by creating a new CDK project for Python in which we will learn and practice CDK testing. First of all, we need a new folder. So I will say here, right here, Python testing, something like this. And inside this folder, I will create a new basic CDK application with Python. Alright, I have created the project. We still need to create the virtual environment. For Linux, I will initialize it like this. And now, first of all, we need to install our requirements, both the basic requirements, but also the development requirements. Basically, we only need the Pytest library alongside the CDK libraries. So I will first install the regular requirements. Alright, and now I will also install the dev requirements. Alright, we now have also Pytest installed. This is our project. And as I said in the introduction to this section, we will have a simple stack. And maybe I will also rename this stack to have a more meaningful name. I will say right here, I will call this simple stack to have no confusion between the test and the stack. Alright, and as I said, we want a Lambda and a AWS bucket just to have something to test on. You can apply what you learn inside this section for your own specific constructs that you want to use. But for me, I will first use AWS Lambda and AWS S3. A very basic Lambda, and then I will also create a very basic bucket. And these are what we can test. We can test the properties of this Lambda and of this bucket. This is the reason I made it versioned, so we won't never deploy this, but we will write tests for this. And one very important point, which is inside our code, usually inside our CDK code, one construct will interact with another construct, and this is also something that we can test. For this reason, I will allow our bucket to be accessed by our cool Lambda with the method, with the function grant read, and this grant read will create a new policy inside our CloudFormation template. This is basically what we will test inside this section. Let's see if everything is working right now. And what's nice about this CDK init is that it puts everything in place for us. This means that I can simply call Pytest and it will execute our tests. And let's see also how our tests are looking. I will look in this unit tests right here. I will just delete everything. I will explain what exactly is happening here inside the next lecture, but for the moment let's see if our tests are working. They should work. So in order to see if the tests are working, I can simply call Pytest. And yes, our tests are found. I mean, our only test is found and is successfully executed. Let's see what is happening inside it and how we can write CDK tests. Now that we have everything in place, let's do this in the next lecture. Alright, we have our test set up. Let's understand what is happening inside this test file, and we'll write our first test inside this lecture. Basically, we want to write a test suite for our simple stack, or for each stack I find it a good practice to have each stack to have its own test file. This is what we are doing right here. And basically in Python we want, if we have test methods, they should start with test underscore and then what exactly the method is doing. What exactly can we first test? Let's start with a simple point. We have, for example, a lambda inside this Python simple stack right here, a lambda function. And basically we can test this lambda function, maybe the runtime. Let's say that we can test this property of our lambda. Let's write this simple initial test inside our test file. First of all, let's start with a meaningful name. So I will say right here, def test lambda props, something like this. Maybe we will test multiple properties. Anyway, it is a good practice to make your tests as small as possible. When they are failing, you get a more meaningful failure message. But what exactly is happening right here in this first test generated by CDK init? Well, the first step inside our test would be to generate a template, like the CloudFormation template, just generate it like we usually generate it. As you can see right here, we have a application object. So any stack needs an application object in order to exist. So we simply are creating a test application object for us. Then we are creating our stack. We give it a name, doesn't really matter. And then we are using a special method from the CDK testing library called template from stack, and basically we are getting the JSON template for our stack object. This is something like a synthesizing step into specifically for testing. Well, let's now that we have our template, we can use it to query for our lambda, and we can query for resources with the method. The most useful method, or the most usual method when we are calling, is the has resource properties. This is the one, and this method basically requires two arguments. First of all, the type of resource that we are searching, and let's check the CloudFormation template for this. To have this, let me call CDK synth to check the CloudFormation template. So I'll call right here CDK synth, and let's see what exactly do we want to test. Alright, we have our template. This is our template, and as I said, I want to test the properties of our lambda. So I will search my lambda. Alright, this is our lambda, and usually we take this type of CloudFormation construct, this is the one, and use it to query our template. So I will get this exact same string right here, like this, and then inside this I will receive with this query method, this exact method will return me the properties of this object. And as I said, I want to check, for example, for the runtime. You know, because I'm lazy, I will just copy and paste this inside the code right here, and this is what we can test. I mean, we can take any entry inside this properties object, like here, maybe the handler, maybe the role, maybe the code, but let's check for the runtime. So let's see if this initial test is working, and then we will do some important optimization. So I will clear the terminal and call Pytest. Alright, the test is passed. If, for example, I have a typo right here, or maybe inside the code, inside my CDK code, I'm not careful and I'm adding some other runtime inside my lambda definition, and I make again a test, this time it should fail with a very meaningful message. This is the important point about good tests. They have meaningful messages, otherwise they aren't so useful. But as you can see, here we are getting the exact meaningful message. We are expecting this, but we are receiving this. Well, this means that our test is working. But there's another important point which I want to talk about, and since we are working with a synthesized template, this synthesize operation is a very long operation, and if we would do this for multiple tests, because we will have many test functions inside this file, we will test for a lot of things, inside this inside our CDK code? Well, we don't want to always have this code in order to receive the template code. This is one reason we should optimize our code, you know, to reduce this code duplication. And another point would be to, since this is a very long operation, we want to make our tests faster by only synthesizing the template once in the beginning of our test suite and then using that template throughout our tests. So let's make this optimization, and we can do it with Python fixtures. For this I will import Pytest, and I will create a initializer method with the definition with the annotation Pytest fixture. If I wouldn't give it this argument that is of scope session, then this method would be called for every test. But since the same template is used, I can only run once this fixture right here. So we want to move this code that is receiving or is returning back our template into one separate file right here, like this. And basically now we can simply return this template from our test. Now what we can do is to receive back this template inside our test methods. So right here I will call this simple template and use it right here. And now we can use this template for all our tests that we will write further on. Let's see if this approach is working. So let me call again Pytest. Alright, this initial test is working. Let's also add one other simple check inside our template. So since we have this lambda properties function, I want to, let's say, another popular test would be the number of resources inside our stack. I can simply check that with our simple template. I can call the method resource count is. This is the one, and with this simple check I want to make sure that inside my template I only have one lambda function, because this is what I configured. If, for example, my template will create maybe custom resources and add multiple functions, then I will be aware of this and I will be able to change my test. But for the moment, let's see if this also is working. So everything works. Inside this lecture we saw how we can make a simple setup and how we can remove the code duplication and make our tests faster. In the next lectures, let's proceed to write more complex tests about maybe the interaction between different constructs inside our CDK code. In this new lecture, we will talk about Python test matchers, and let's start with a simple example and with a simple problem, and then we will get into a very nasty piece of code, but let's start simple. First of all, let's see that we want to check the runtime for our Python lambda, but we don't want to be so strict. Let's say that we want to check the runtime to be Python, but maybe we want to be open to other Python versions. Well, how we can make this into a test? We need a way in which we can specify that this runtime property of our lambda contains the word Python, but maybe other version we don't really care too much about it. We can achieve this goal with a very cool library or a very cool part of CDK library called matchers. So first of all, let's import it. So from AWS CDK's assertions, I will import the match object, and let's now write a new test to understand the concept first of all. And I will call this test lambda runtime with matcher to know that we are using a runtime matcher. Well, and as I said, we want to check the runtime of our method, but first of all, we only want to say that it contains the Python code, the Python word. Well, instead of runtime right here, we can call the match, and we can call the method string like regular expression. And basically, if now we only pass a part of our string, the Python part, then it should match this exact Python version that is currently present inside the template. Let's see if this works. Pytest. Alright, the test works, so basically this is the way we can use matchers. This is a simple example, but let's take a different approach and let's write a more complicated example. For example, first of all, let's check our template file and let's say that we want to check the interaction between our function and our bucket. And if you remember, we said that our function has the right to access our bucket, and that access translates into an IAM policy object. Basically, we can use matchers to go into these IAM policy objects and check the different values of these different keywords. But the problem is for example, here our template is generated with an AWS IAM policy entry, but its a resource that it affects somehow resembles the name of our bucket or the ID of our bucket, which is simple bucket, but then we also have a randomly generated part that is generated by CDK, so we can't know beforehand this value. How we can test this interaction? Well, this is a good point to start to talk about more complex matchers in CDK. So let me first write the test and then I will explain it. And a piece of warning, it will be the ugliest thing you've seen inside this course until now. Well, this is our code that is using matchers, and we want to test the connection between our bucket and our Lambda. And that connection translates into an AWS IAM policy construct. And since we want to check the different entries inside this object, I can use directly the match object-like function before using our object. Before passing directly the object, I'm wrapping the object that I'm expecting into this match object like. We have two options right here, object like and object equals. Object equals will expect all the entries inside our properties. Object like will only take different entries that we specify. For example, here we are only specifying the policy object, the policy document. This is the difference between object equals. It expects all the entries. Object like will be happy if it finds only maybe one entry or more. And what is happening right here? I'm going deep inside the structure of our object, and in the resource I'm trying to get a match string like regular expression and with the ID of the bucket that we know beforehand. I'm telling you from the start this test won't work, and let's see why. We will solve this problem yet with another matcher, but first of all let's see the error. Alright, the error tells us that it received too many elements in our array. It was expecting one, and when I'm talking about the array is this array right here, and here we are passing one entry right here at the resources, but it says that it got two entries right here. And usually when we want to write, a very important point about writing CDK tests is that we need to understand very well what is happening inside our CloudFormation template. Let's check it once again. And if we will look at this resource get attribute right here, we also get another entry with the fn join, which basically checks the same thing but with an fn join. I don't want to test again this simple bucket right here, but I have a simple matcher to solve this problem. So basically the test tells us that it expects yet another entry right here. For this I say, hey, if you expect yet another entry, I'll give you yet another entry and maybe any value. Any value will do just fine for my particular test. Let's see if this is working. Alright, this time the tests are passing, and I'm aware that these two examples were like extreme. Maybe if the first example using matchers was just very logical, maybe this one is a little more complicated, but the key is to look careful into your CloudFormation templates. Let's proceed into the next lecture and talk about yet another testing technique that we can use with CDK, and we are talking about argument captures, which are a little more convenient and nicer to use than matchers, in my own humble opinion. Let's now talk about another testing technique with CDK and Python, and maybe a nicer testing technique, a technique that will help us to write more easier to read tests for our CDK code. We are talking about captures, and we first of all we import them again from AWS CDK assertions. I will import right here capture, the capture import. Right here, let me also have my template open, and let's see how we can use this capture. And first of all, let's start with the problem that we want to solve. We are still talking about our IAM policy for our connection between our Lambda and our bucket. And let's say that we want to make sure that the actions presented in this IAM policy are this exact one that concerns S3 get object, S3 get bucket, get object, and maybe not the administrator access or anything dangerous right here. Let's say that we want to test for these specific actions right here. Well, of course, we can simply make a test that will we'll write all this JSON structure inside our code, and it will be just fine. But let's write tests in a more meaningful and easier to read way. So let me first write the test definition. So we start with a object of type capture. We are creating a new capture, and I've called this object Lambda actions capture. And then we are making the same query inside our IAM policy, just like we did it with the matchers. We will do it the same for this IAM policy, but this time, instead of specifying directly our entries right here, I'm getting this has resource properties for our IAM policy. We are going into the policy document statement, and in the end we are reaching the action. And here, if we are specifying as action an object of type capture, then CDK will save the contents of our object inside this capture. And now we can use this capture to make assertions for our CDK code. So let me first also create an object with our expected actions. So here I'll say expected actions, and these are these ones right here. I can simply take this array right here and put it right here. These are our expected actions, and now I can simply write my query. And if you have maybe Pytest experience, this is the first time when we are writing a classic assert. So we want to make sure that our Lambda actions capture, and basically this is a strange object. When we are capturing an array, we should use the sArray object. And if we are capturing another type of object, maybe a string or a number, we should use the appropriate method, otherwise we would get an error. Our capture is an array, so I will call as array method. We want this to be our expected actions. All right, let's see if this test is working. So, all right, I have a small error. Let me check it. Arrays. Oh, okay, I get it. I get the error, and this is a very interesting error when you are testing for arrays in different languages. As you can see here, we are getting an error that this S3 get object is not equal with this S3 get bucket entry, and this is an error not from CDK, but this is an error from our Pytest. Basically, the way CDK generates this template is different from run to run, because maybe there's a different order when this is running. So we want to assert for this array regardless of their order inside the array. And for this I can make sets from this. I can use the sorted function, and I can sort these arrays before comparing them. I can say right here sorted this one and this one. And now everything should be all right. Let me check once again. And yes, this time things are working better. So this was the way in which we can use test captures with AWS CDK. And as a side note, and we saw how we can assert arrays regardless of their order in Python. Let's proceed into the next lecture and talk about testing snapshots in CDK. Let's now talk about yet another way in which we can test our CDK code, and I'm talking about snapshot testing. And this is a way of testing I don't use too often, even if we have the functionality inside CDK. The documentation is still scarce for Python, but still maybe you will prefer it, and I will show you how to do it. Basically, snapshot testing means taking a snapshot, usually in form of JSON or something related, and taking an object and comparing it to the expected snapshot. Simple as that. The problem with snapshot testing, especially for CDK, is that we are working with many automatically generated random values. So this means they are not too friendly with snapshot testing. But I will show you how to do it, and maybe if you like it, you can use it inside your tests. The first step that we need to take is to install the library that CDK uses for snapshot testing. It is not included in the project, so we need to install it first of all ourselves. And the library is called CRUPy. Alright, I have installed it, CRUPy. Alright, and now basically let's write a new test that uses snapshots. Basically, let's say that we want to test only our buckets inside our template, so where we are having our buckets. This is the one. Let's say that we want to take all the contents from our bucket and test them inside a predefined snapshot. Basically, we can take this whole construct from our template and compare it against a snapshot. Well, first of all, let's take the bucket, and we can take it from our simple template with the find resources method. And this will be our bucket template. And as you can see here in the test method definition, I've always also added this new snapshot entry. This snapshot entry will be injected by the library that we just installed. You know, this is what it will do. And now I can simply compare the two. And I can say right here, assert that our bucket template is our snapshot. Basically, this is the whole point of snapshot testing. It is very easy to set up, but again, it is hard to maintain because there will always be changes inside our generated code. And maybe when you will see a change, you won't know if something should really be changed inside your code, or you have a mistake and you should fix it. But let's see if this is working. And first of all, we should generate our snapshot. So here I'll first call Pytest with the argument snapshot update. This is the one, and this snapshot update argument will only work if you have the CRUPy library installed. Alright, and now we can see the option and the entry that one snapshot was generated. And if I will look to my test, I will have a new folder inside my unit tests right here called snapshots. And basically this is a representation of the object at the time the snapshot was generated. This is the one. And now every time our test will run, we'll compare the two entries, the bucket template that we get with the find resources method inside from our generated template, and then it will compare it against our snapshot. If I will now run my test only with the Pytest, everything works just fine. But if something will be changed inside my definition, maybe if I go to my code, let me go to my code and try to mess up with something, maybe where we are making our bucket version and I will make this false, and let me run the test again. You'll see the problem that we are getting. You'll see that now we don't have these properties deletion policy retain, and these properties are not there right there because I said that the version should be false. If I will change this back to true, then my test will run just fine. So basically this was the way in which we can use snapshot testing in Python, and with this way we concluded, or we touched the most important ways in which we can write tests for Python. Well, we reached the end of the course, and the occasion for me is to say thank you for watching this, and to say that I really hope that the information presented here was of value for you. And this being said, I thank you very much and have a great day. And also don't forget to like and subscribe and so on.